All right, so this week, you guys sent in some really, really interesting stuff about that earthquake that hit Thailand and Myanmar back on March 28th,
Yeah.
2025. And
Big one.
big one, yeah. So we've got some articles that kind of dig into, the whole tectonic plate thing, and then also just, specific reports about this earthquake. And I think what we want to do is kind of go beyond just like the immediate news reports
Absolutely.
and really understand like the how and the why behind this whole thing.
Yeah, I think it's fascinating because it allows us to go into, the fundamentals of how the Earth works.
Right.
And really, dissect, okay, well, why did this happen in Myanmar, but we felt it so strongly in Thailand?
Yeah, and I think one of the sources said something that was kind of like blew my mind, which is that like, the Earth's crust isn't just like one solid shell. It's actually like all these different
Right.
pieces.
Pieces, exactly.
And I guess the analogy is like a cracked apple skin or something.
Yeah. Yeah, that's a really, it sounds so basic, but it's actually a really good analogy because, the Earth's crust, which is the outermost layer that we live on, is broken up into these, what we call tectonic plates.
Okay.
And they vary in size,
Mm-hmm.
but they're all essentially kind of floating on this semi-molten rock underneath, which we call the mantle.
So like those pieces of apple skin, these
Oh, yeah.
huge plates are kind of like constantly in motion,
Exactly.
which is kind of crazy to think about.
Yeah, we don't feel it in our daily lives because it's so slow.
Right.
It's, in the order of centimeters per year.
Okay.
But over millions of years, that really adds up.
Yeah.
And essentially, these plates are like constantly bumping and grinding against each other or pulling apart or sliding past each other.
Right. And I think, the example that one of the sources used, which I thought was super helpful, was talking about like, how the Andes Mountains were formed?
Right.
Like how that was because of like the Nazca Plate and the South American Plate like colliding. And it just, like over millions of years.
Pushing up against each other.
It's just like crazy to think that something that seems so small, like just a few centimeters a year,
Yeah.
can create something so massive.
Yeah, exactly.
Yeah.
It really puts into perspective the immense power of these plate movements, even though they happen so slowly over geological timescales.
Yeah, and this motion,
Right.
that's what kind of leads to like not just, mountains being formed, but also events like earthquakes.
Yeah, exactly. The slow, continuous movement of tectonic plates is really the driving force behind all the major geological activity that we see,
Right, yeah.
including earthquakes and volcanic eruptions. Now, when we specifically talk about earthquakes, it's not just the gradual drifting of the plates that causes it.
Okay.
It's what happens when that movement gets kind of stuck.
Okay, yeah, so like friction.
Exactly. Friction plays a huge role.
Yeah.
And the example that everyone always uses is the San Andreas Fault
Right.
in California,
It's like the classic example.
where you have these two plates trying to slide past each other.
Yeah.
But because of the friction along the boundary,
Right.
it prevents a smooth, continuous slip.
Yeah.
So what happens is over time, this tremendous stress builds up
Okay.
along that fault line.
So it's like a spring that's being wound tighter and tighter.
Exactly.
That's a really good analogy.
And then eventually it's got to give.
Exactly.
Right.
When the accumulated stress exceeds the strength of the rock along the fault, it ruptures
Okay.
or fractures. And the sudden break allows the plates to finally move. And in that instant, a massive amount of stored energy is released.
And that's the earthquake.
That's the earthquake.
Yep.
And
Now-
this energy radiates outward
Wow.
from what we call the earthquake's focus, which is the point of rupture beneath the surface.
Okay.
And it travels through the Earth's layers in the form of seismic waves.
And that's what we feel is the ground shaking.
Exactly.
Yeah.
And how intense the shaking is depends on, how much energy was released, how far away you are from the epicenter, all sorts of things. Okay, so we've got kind of the general picture.
Yeah.
These plates are always moving.
Constantly moving.
Friction causes this tension.
That buildup of stress.
And then bam,
And then bam.
it releases the earthquake.
Exactly.
Okay, so now let's zoom in on like the specific event
Right.
that we're talking about here. This magnitude 7.7 earthquake that happened near Mandalay,
Yeah.
Myanmar, back on March 28th, 2025.
Correct.
And, really was felt, I mean throughout the region.
It was huge.
But it was felt really strongly in Thailand too.
Absolutely.
So what is it about like that region
Right.
tectonically that kind of set the stage for this?
Yeah, so Myanmar is situated in a very, very seismically active zone.
Okay.
It's right at the boundary
Mhm.
where the Indian plate is colliding with the Eurasian plate,
Okay.
which is a huge plate.
Yeah.
And within that zone There's a lot of geological interaction going on, but a really key player here is something called the Sauging Fault.
Yeah, the Sagaing Fault, that name really jumped out at me
Yeah, it's a big one.
when I was looking at this stuff. What is that exactly?
So the Sagaing Fault is a major strike-slip fault
Okay.
that runs pretty much north to south through Myanmar.
Okay.
And when we say strike-slip,
Mm-hmm.
that means the plates are moving horizontally.
Okay, so like side by side.
Exactly, side by side, rather than like colliding head-on or pulling apart.
Got it. So kind of like the San Andreas Fault that we were talking about?
Yeah, very similar to the San Andreas Fault.
Okay.
So it's that grinding motion.
Yeah.
And the Sagaing Fault essentially marks the boundary between the Burma Plate and the Sunda Plate,
Okay.
which are both actually part of the larger Eurasian Plate system.
Okay. Got it. And so just like with the San Andreas Fault, I'm guessing this movement along the Sagaing Fault isn't always smooth either?
Nope, not at all.
There's going to be some friction there.
There's a ton of friction,
Okay.
and that's what causes the problem.
Okay.
So over, decades, centuries,
Yeah.
stress builds up as these massive plates try to grind past each other,
Mm-hmm.
but they get locked by the friction.
Yeah.
And then
You're
eventually,
seeing, it's like the spring all over again.
and being wound and welded and wound.
Yeah. And eventually the stress exceeds the strength of the fault and bam,
Not quick.
earthquake.
Okay, and so we know this was a, magnitude 7.7 earthquake.
Yeah, big one.
That's pretty serious.
Very serious.
And one of the things that the sources talked about as to like why this earthquake was so destructive
Mm-hmm.
was how shallow it was.
Yeah.
Like it was only about 10 kilometers below the surface.
That's really shallow.
Yeah. So how does that
Yeah.
make a difference?
So when you have a shallow earthquake, it means that the energy that's released during the rupture has less distance to travel to the surface.
Okay.
So the shaking at the surface is going to be much stronger.
Then if you had an earthquake of the same magnitude,
Okay.
but it was deeper down.
Yeah.
So you can kind of think of it like
Mhm.
setting off a firework.
Okay.
If you set it off close to you,
Right.
it's going to have a much bigger impact.
Right. Yeah. The closer you are to the explosion, the worse it is.
Exactly.
Okay.
The closer you are to the source of the energy release,
Right.
the more you're going to feel it.
Okay. So it's not just about like the magnitude of the earthquake. It's
Right.
also about how deep it is.
It's also about the depth.
Got it. And then there's another thing that I thought was really interesting in the sources, which was they talked about how the type of movement along the Sagaing Fault
Right.
also made it more destructive.
Yeah.
So how so?
So with the Sagaing Fault, remember, it's that horizontal strike-slip motion,
Right. The
side-by-side grinding.
Yeah.
And a lot of buildings are designed to withstand vertical forces,
Okay.
like, the weight of the building itself,
Yeah.
or the up and down shaking that you might get from some earthquakes,
Right.
but they're not as good at withstanding horizontal forces,
Okay.
the side-to-side motion.
Got it.
So when you have this strike-slip movement, it can really put a lot of stress on buildings.
So it's not just how much the ground shakes, it's also like the direction of the shaking.
The direction is really important,
Wow. Okay.
and that's why you see a lot of damage.
And one of the things that the sources kind of pointed out too is that
Mhm.
unfortunately a lot of the areas that were affected
Yeah.
by this earthquake just don't have earthquake resistant infrastructure.
A huge problem.
Yeah. So that's a recipe for disaster.
Yeah. If the buildings aren't built to withstand these kinds of forces,
Yeah.
they're much more likely to collapse.
Right. And that obviously leads to more casualties and just destruction in general.
Absolutely.
Exactly.
It's a major vulnerability in a lot of seismically active regions around the world, unfortunately.
Yeah, and it's interesting because this earthquake was centered in Myanmar,
Right. Okay.
but it was really felt all the way over in Thailand.
Yeah, Thailand felt it strongly.
Like even in Bangkok,
Mm-hmm.
which is like, 1,000 kilometers away from the epicenter.
Sure. It's quite a distance.
And I know that one of the sources talked about like a 30-story building collapsing in Bangkok.
That's all
And
that.
just like people reporting shaking
Mm-hmm.
throughout the city.
Yeah, it was widespread.
So why would an earthquake so far away
Right.
have such a big impact?
Well, one thing to remember is that seismic waves can travel huge distances through the Earth,
Okay.
but the intensity of the shaking that you feel in a particular location
Mm-hmm.
is also really influenced by the local geology.
Okay.
And in the case of Bangkok, a
Yeah.
big factor
Mm-hmm.
is that the city is built on these really thick layers of soft sediment.
Okay, so what does that mean, like soft sediment?
So it's basically, loose soil, clay, sand,
Okay.
that kind of stuff.
And how does that make a difference?
Well, when seismic waves travel from denser rock into these softer layers,
Mm-hmm.
they actually slow down.
Okay.
But as they slow down, their amplitude increases.
Okay, so what does that mean, like the amplitude increasing?
So it's basically the intensity of the shaking.
Okay.
It gets bigger.
So it's kind of like when waves approach a shallow beach,
Exactly.
they get taller.
They get taller.
Okay.
And so the soft sediment underneath Bangkok is kind of like a bowl of jelly.
Ah.
It's amplifying those seismic waves that are coming from Myanmar.
So even though Bangkok was pretty far away from the actual earthquake,
Yeah.
the ground that it's built on basically made the shaking worse.
It magnified the effect.
Okay, that's really interesting.
Yeah, it's a really important thing to consider when we think about earthquake risk.
Yeah, so it's not just about like how far away you are from the earthquake. It's
Exactly.
also about what the ground is like.
Absolutely.
Notes you.
Yeah, the local geology plays a huge role.
Okay, so let's kind of recap everything we've talked about. You sent in these sources about this big earthquake in Myanmar. We
Right.
talked about tectonic plates,
Of fundamentals.
the buildup of stress,
And then the release of energy.
the earthquake.
We talked about the sagging fault
Yeah.
specifically,
Right.
and, the type of movement that happens there.
The strike slip.
We talked about how shallow the earthquake was,
Mm-hmm.
and also just the lack of earthquake-resistant infrastructure
Sadly.
in a lot of these places.
Yeah.
And then we even talked about how, even though Thailand was pretty far away
Mm.
from the epicenter,
Right.
the geology of Bangkok actually made the shaking worse.
Absolutely.
So, this has been like a really fascinating
Yeah, it's been great.
deep dive.
Yeah, thanks for sharing those sources.
Yeah, thank you guys for sending those in. And, hopefully this has given everyone listening
Right.
a better understanding of, like,
A more nuanced view.
yeah, a more nuanced view of what caused this earthquake.
Yeah. And like what the consequences were.
Yeah, and I think it really highlights just how dynamic our planet is.
Mm-hmm.
These forces are constantly at work beneath our feet.
Right.
And I think understanding that
Yeah.
is key to mitigating the risks
Absolutely.
in the future.
So here's a question for everyone listening.
Right.
We talked about how interconnected
Mhm.
the Earth's plates are and how, this earthquake happened in Myanmar,
Right.
but it was felt all the way in Thailand.
Absolutely.
What other seemingly distant events
That's a good question.
might be connected
Yeah.
to these forces that are happening beneath our feet?
And that's something for all of us to think about
Yeah.
because, stresses in one part of the world could actually be influencing what's happening somewhere else.
Right.
And I think understanding these connections
Yeah.
is crucial for
Yeah.
how we plan our cities,
Yeah.
how we build our infrastructure,
Mm-hmm.
not just in places that are known to be earthquake prone,
yeah.
but also in places that might be affected indirectly
Wow.
by these kinds of events.
That's a great point.
Yeah,
So, yeah, lots to think about there.
absolutely.
Thanks again for listening, everybody.
Thanks, everyone.
And we'll catch you next time.
See you next time.